Hello everyone. In this video, we will be discussing about 10 MCQ questions from the chapter Work, Energy and Power of Class 11 Physics, which would help you to crack KVS PGT Physics, NVS PGT Physics as well as Ekalavya Model Residential School EMRS PGT Physics. In this video, we will be discussing 10 questions from this chapter. The rest of the questions will be discussed in the next video, which will be available from the playlist. Let us see the first question. When a body is moving in a circular path, work done will be, four options are there, positive, negative, zero, none of these. See, the body is moving in a circular orbit. So we know that when a body is moving in a circular orbit, there will be a force which is acting towards the center of the circle, which is actually called as the centripetal force. And you see the displacement of this particle or this body at any point of its motion will be along the tangent drawn at that point of its orbit. So you see all the time the displacement and force, they will be perpendicular to each other. That is the angle between them, force and displacement will be 90 degree. Okay, we know that work done is actually the dot product of force and displacement, which can be written as F into S into cos of angle between them. Here theta is 90. We know that cos 90 is equal to 0. So 0 into force into displacement will give you 0. That is, the correct answer is option C, 0. Now let us see the second question. When a body moves with a constant speed along a circle, the same case, no acceleration is produced in the body. It was wrong because you see, when this body is moving in a circular orbit, there is a centripetal acceleration for this body. So no acceleration is produced in the body. This statement is wrong. Its velocity remains constant. No, it is also wrong. It is moving with a constant speed. But you see, velocity is speed with direction. That is, you see, at each time its velocity will have different directions, which is drawn at that point along the tangent. So you see, its velocity remains a constant. This is also wrong. Then you see the statement D, no force acts on it. This is also wrong because you see there is a centripetal force acting on it. Then no work is done on it, just like we discussed here. No work is done on it. This is the correct statement. Now let us see the third question. What is vector F dot vector ds? Dot product of force and displacement, what is that? It is the work done, no? So option D, work, is the correct option. Now let us see the fourth question. A man lifts 20 kg mass up to 2 meters. The work done by him is. See, we know that work done is actually the dot product of force and displacement. When a man lifts a 20 kg mass, that is, the force is acting in the upward direction. And you see the displacement, it is 2 meters, which is also in the upward direction. So the angle between the force and displacement, that is equal to 0. So the work done W equals F into S into cos of angle between them, that is cos 0, which is equal to, see the force F, you see that force F, that will be equal to the weight of the body, which is mg. So M, mass of the body, which is 20 kg, G, 9.8, into displacement of this body is 2 meters, into cos 0 is 1. When you do this calculation, 9.8 into 2 into 20, you will be getting almost 392 joule, which is not there in the option. So the correct option is option C, none of these. Now let us see the fifth question. A body constrained to move in the y direction, that is, its displacement is along the y direction, is subjected to a force given by vector F equals 2 I cap plus 15 j cap plus 6 k cap Newton. What is the work done by this force in moving the body a distance to 10 meters along the y axis? So you see, here the force given in vector form in its component form as 2 I cap plus 15 j cap plus 6 k cap Newton. And you see, the body covers a distance 10 meters, that is, its displacement is 10 meters along the y-axis. So displacement vector S can be written as, or you can take it as vector D, no problem. Both are displacement vectors. 10 meter along the y-axis now. So magnitude is 10 and 10 meter. It is along the y-axis, so the unit vector which is used to show the direction along the y-axis is j cap, so we can write it as 10 j cap. What about the work done? Work done is the dot product of these two, force and displacement, that is 2 I cap plus 15 j cap plus 6 k cap dot 10 j cap. Okay, that is you can write it as 2 I cap plus 15 j cap plus 6 k cap dot, there is no I term here, so 0 I cap, 10 j cap plus there is no k term here, so 0 k cap. Okay, now you know how to find the dot product of two vectors now. 2 into 0, that is 0, plus 15 into 10, 150, plus 6 into 0, 0. So this is equal to 150 joule. So now let us see the sixth question. A 60 kilogram weight is dragged on a horizontal surface by a rope up to 2 meters. If coefficient of friction is mu equals 0.5, the angle of rope with surface is 60 degree and g equals 9.8 meter per second square, then work done is 4 options are there. So let us consider a horizontal surface. Let this be the horizontal surface. There is a 60 kilogram weight. So suppose this box is having a it is having a mass 60 kilogram now, so it is actually the mass, so it is actually the 60 kilogram mass. Okay, so it is dragged on a horizontal surface. So suppose it is dragging along this direction by a rope. So there is a rope connected with this. So suppose a rope is connected to this point, and you see the displacement is given as 2 meters, coefficient of friction is given as 0.5. The angle of rope with surface, that you see, suppose there is a rope here. The rope makes an angle 60 degree with the surface. This is a horizontal surface. So if I draw a dotted line here parallel to this horizontal surface, this angle is 60 degree. Okay, this is that force F by which this mass is dragged along this horizontal surface. So we know that there are many forces acting on this box of mass 60 kilogram. One is the weight W equals mg acting in the downward direction. Another one is the normal reaction force which is acting in the vertically upward direction. It must be the vertically upward one. And you see, since it is dragging along this direction, a force of friction will be acting along the surface but in the opposite direction of its motion. So there will be a force of friction. I am taking it as, it will be the kinetic friction because the box is in motion. So I am taking it as Fk. We know that this Fk is actually equal to mu k into n, where mu k is the coefficient of kinetic friction, n is the normal reaction force. Okay. Now you see, I just extended this force to this point, and you see this force makes an angle which is 60 degree with the horizontal surface. This force can be resolved into two components. One is along the x direction, another one is along the y direction. Okay, the component of force along the x will be F cos 60 and the component along the y direction will be F sin 60. Okay, F cos theta, F sin theta. Now in equilibrium we can write the force which is acting in the backward direction will be equal to the force acting in the forward direction. That is, we can write Fk is equal to F cos 60. And you see, this Fk, it is actually equal to mu k into n. So this is equal to F cos 60. Now what is the value of cos 60? Cos 60 is 1 by 2. So F by 2. Okay, we actually want to find out the work done. Work done is the dot product of force and displacement. So we want to get an expression for this force. Displacement is given as 2 meters. Okay, so from this we can write N is equal to, normal reaction force N is equal to F by 2 into mu k, which is equal to F by 2 into coefficient of friction is given as 0.5. Okay, so this is equal to F by 0.5 into 2 is 1. That is, N is equal to F. Alright, I am taking this as equation number 1. Now you see, from this upward and downward forces, we can write this N plus, in the upward direction there are two forces acting. One is N, another one is F sin 60. So this will be equal to the downward one, which is mg. So from this we can write N is equal to mg minus F sine 60. Okay, so what is sine 60? Sine 60 is root 3 by 2. So we can write it as mg minus F into root 3 by 2. Okay, I am taking this as equation number 2. So from equation number 1 we have N equals F. From equation number 2 we have N equals mg minus F into root 3 by 2. We can equate these two equations. When we equate equation number 1 and 2, we can write F equals mg minus root 3 f by 2. If we take this minus root 3 f by 2 to this side, this becomes plus. So f plus f into root 3 by 2 equals m into g. Okay, from this if we take f as common, we can write 1 plus root 3 by 2 equals m into g. Okay, that is f into cross multiplication 2 plus root 3 by 2 equals m into g. Okay, or we can write f equals mg divided by, if we take this term to this side, comes to the denominator. So 2 plus root 3 by 2 multiplication with reciprocal. So 2 goes to the numerator. So 2 mg divided by 2 plus root 3. Okay, that is f equals 2 into what is m? Mass, which is 60 kilograms. So 60, g value 9.8 divided by 2 plus root 3. Root 3 is actually 1.732. Okay, I am approximating it to 1.73. So 2 plus 1.73 will give you 3.73. Okay. So you see, f equals 2 into 60 into 9 divided by 3.73. When you do this calculation, you will be getting it as 315.28, which can be approximated to 315 Newton. See, we are asked to determine the work done. Displacement is given as 2 meters. So work done, it is actually the dot product of force and displacement. Okay, so here force is 315 Newton and displacement it is 2 meters. Work done, it is actually vector f dot vector s, not cross, vector f dot vector s, which is equal to f into s into cos of angle between them. Okay, you see, this is equal to force is almost 315 Newton, displacement is 2 meters, then angle between them which is given as 60, so cos 60. Okay, so this is equal to 315 into 2 into cos 60 is 1 by 2. 2 cancelled. So you will be getting it as 315 joule. So option B, 315 joule is the correct option. Now let us see the 7th question. A horizontal force of 5 Newton is required to maintain a velocity of 2 meter per second for a block of 10 kilogram mass sliding over a rough surface. So you see the velocity of the block is given as 2 meter per second. Force is given as 5 Newton. Mass of the block is given as 10 kilogram. Now the work done by this force in 1 minute is. So time it is given as 1 minute. 1 minute is actually equal to 60 seconds. We want to find out the work done. So we know that work done is actually the force into displacement. Okay, force is given as 5 Newton. What about displacement? We have velocity is equal to displacement by time taken. So displacement is equal to velocity into time taken. Velocity is 2 meter per second. Time taken is 60 seconds. So 120 meter is the displacement. So work done will be force into displacement 5 Newton into 120 meters, which is equal to 600 joule or 600 Newton meter. So you see option D, 600 joule is the correct option. Now let us see the 8th question. A point of application of a force vector F equals 3 I cap minus 2 j cap plus 2 cap Newton is displaced by displacement vector x equals 3 I cap plus 2 j cap plus 5 k cap meter. Then the work done by this force is, 4 options are there. So you see the force as well as the displacement are given in their component vector form. So we know that work done, it is actually the dot product of this force vector and the displacement vector. Okay, so which will be equal to 3 I cap minus 2 j cap plus 2 k cap dot 3 I cap plus 2 j cap plus k cap. Okay, this will be equal to what? 3 into 3, 9 plus minus 2 into 2, which is minus 4, plus 2 into 1 k cap. No, so 2 into 1 is 2. So this is equal to 9 minus 4 plus 2. 9 minus 4 is 5. 5 plus 2 is 7. So the correct option is option B, 7 joule. Now let us see the ninth question. A body is acted upon by a force vector F equals minus 12 I cap plus 5 j cap. The work done by the force in moving the body from the origin to a point, coordinates of which are 5, 4 s dash. So you see force is given in its component vector form. And you see the body is displacing from the origin, that is from the coordinate 0, 0 to the coordinates 5, 4. So this is like x1, y1, this is like x2, y2. So what about the displacement vector? It will be x2 minus x1 into I cap plus y2 minus y1 into j cap. So this displacement vector will be equal to what? 5 minus 0, which is 5 into I cap plus 4 minus 0, which is 4 into j cap. So you see the force work done is actually the dot product of force and displacement. So force is minus 12 I cap plus 5 j cap dot 5 I cap plus 4 j cap. This will be equal to what? Minus 12 into 5, minus 60 plus 5 into 4, 20, which is equal to minus 40. It is the work done. So unit is joule. So minus 40 joule is the correct option. Now let us see the 10th question of this video. A force vector F equals 5 I cap plus 3 j cap Newton is applied over a particle which displaces it from its origin to the point vector r equals 2 I cap minus j cap meter. So displacement will be this itself because it has displaced from the origin. No? The work done on the particles. So again we have work done is equal to vector F dot vector S. So here the displacement is given as vector r. So vector F dot vector r. Vector F is 5 I cap plus 3 j cap dot vector r is 2 I cap minus j cap. So when we take the dot product, 5 into 2, 10 plus 3 into, this is minus j cap means minus 1 into j cap. So 3 into minus 1 is minus 3. Okay, 10 minus 3 is 7. It is the work done, so unit is joule. So plus 7 joule is the correct option. So, in this video, we have discussed about 10 questions from this chapter, Work, Energy and Power of Class 11 Physics, which would help you to crack the PGT Physics exams of KVS, NVS, EMRS, etc. I hope it is clear to you. We will be discussing more questions from this chapter as well as from other chapters as well, which will be available from the playlist as part 1, part 2, part 3, etc. Thank you.